Okay, in this question, body covers half the distance with velocity v1, the remaining part of the distance with velocity v2 for half time, and v3 for other half time. So here it is. Let us suppose AB, it is the path, and half the distance it is traveling. Let us suppose distance is 2x. So here it is x, and other half is again x, and in this it is traveling with velocity v1. So time taken here will be t1, that is equal to distance by speed. So half the work we have done. Now for other half, the problem is here they have given that the time taken for this other half, they have divided it into two parts, and if time taken here is let us suppose capital T, then for half the time it has traveled with velocity v2, and for other half time it has traveled with velocity v3. But that's for sure that in the time t it has traveled the distance x. So how are we going to solve this? This part is so sure for first half of distance. Time taken t1 is equal to x by v1. Okay. Now for second half, I am dividing it into two parts. Let time taken is capital T. So here distance traveled will be v2 t by 2, and for other distance I mark it distance 2, and this as distance 3 is v2 t by 2, or they have used the term velocity, so we will call it displacement, and they haven't given, so we will assume that it is in a straight line, because otherwise it has a different meaning. Displacement cannot be added at our choice. Okay. So there is no harm if I use the term distance here, no problem with that. Okay. So total distance will be x. If we add both of them, that will be x, this part. So that will be equal to v2 t by 2 plus, oh sorry, v3 t by 2. And from here we can find t, which will be 2x. We'll take 2 common, cross multiply it here, and then there is v2 plus v3 multiplied by t. So t will be 2x by v2 plus v3. Now we have total distance 2x and total time this much. We can apply it here, but there is lesser space, so let me first manage some space. Yeah. Okay. So average speed or average velocity as they have given is equal to net displacement, that is 2x, divided by total time. Total time is this t1 plus this capital T. So here it is 2x divided by x by v1 plus 2x by v2 plus v3. If we further solve it, we will get 2x divided by x v2 plus v3 plus 2x v1 v1 v2 plus v3. So we will take x common, it will be get cancelled. So finally it will be 2 v v1 v2 plus v3 divided by 2v1 plus v2 plus v3. That's all. This is the final answer. So question was a bit tricky, otherwise it was so simple one. The statement was tricky. Next, okay. A car standing 200 meters behind a bus at rest. The two start moving at same time but different acceleration. The bus has acceleration 2 meters per second square and car has acceleration 4 meters per second square. Find the time taken by car to reach the bus. There are two approaches we can use. We can apply second equation of motion and just equate both of them. We can easily find it. So that can be an approach, but there is a shortcut also. And in the shortcut we will as initially I told you that we can study motion with respect to our reference point. So if we consider reference point as that car or bus, then it will be easier for us to solve this problem. Otherwise that approach is also correct, like if we solve for bus separately and for car separately and then just equate, there will be two equations, we solve that those equations and we will get the answer easily. But there is another way, and see if you like that method. That is much easier and a comprehensive method which can be used in some similar conditions, similar cases, and in other complicated problems also. This one is little bit straightforward. So what my approach is, see, a bus and a car both are, oh my god, okay, to start moving at same time. Initial velocity is 0 and their acceleration uh, bus has acceleration 2 meter per second square and car has acceleration 4 meter per second square. Sorry, I'm doing a mistake. Car is standing 200 meter behind. So mm, so there is the bus, and 200 meter behind there is a car. Now drawing is correct now. So relatively, if you see this question in a different perspective, then relatively car has traveled on car has to travel only 200 meter to reach the bus. So what we can do, we can uh, observe this motion with respect to bus. Means initial velocity of car is 0 and initial velocity of bus is also 0. But if it would not be 0, then we have to take relative velocity of car with respect to bus. We are considering bus as a reference. We are observing this motion with respect to bus. So that will be UC minus UB. Ultimately, this is equal to 0. Actually, one thing is not given here, that both are moving in same direction. Either I have missed it or it wasn't in the question. But remember this thing, it will catch the bus only if it is moving, both of them are moving in same direction. So anyway, now there is directly, now we can do it directly. Relative position or relative displacement of car with respect to bus is 200 meter. Bus will travel some distance and car will travel that distance plus this 200 distance, and both will get cancelled, only 200 will be remain there. Let us suppose bus traveled x distance. So car is traveling 200 plus x, and if we subtract both of them, then it is 200 meter. Okay. Now their relative acceleration. So both are moving in same direction, so we will subtract their acceleration also. So till now you know that if two objects are moving in same direction, we subtract their velocity in order to find their relative velocity, and if they are moving toward each other, we add their relative velocity. In fact, this is true for speed also. So also with acceleration we do the same thing, and I will explain this relative motion effect comprehensively in motion in 2 dimension. Okay. By the time, just recall that concept. When two objects move in same direction, we subtract their velocity. So also their acceleration. So acceleration of car minus acceleration of bus. So that is 4 minus 2, that is 2 meter per second square. Now we can easily find, we can apply this equation of motion as equal to ut plus half at square, but we are using that relative motion. So this is 200, it is 0, and this is half into 2 t square. It will get cancelled. So t will be root of 200 second. You can find it of your own. Try or if it is an MCQ, you can just check the answer whether you have to find its root or you have to leave it as it is. Now, my favorite question. From the top of a tower of height 200 meter, a ball is dropped freely. Part 1. Part 2, dropped downward with velocity, means thrown downward, and thrown upward with velocity 10 meter per second. Find the time taken by the ball to reach the ground. Means here it's thrown in such a way so that it will never fall back on the building, but it missed the building and will fall down to the ground. So yeah, if this is a building, I'm generalizing it in such a way. So here there is the ball, we have placed it on a plank or something, and we have just dropped it. Okay? Dropped means initial velocity is 0. Yeah, we know that for downward motion acceleration is plus g. Well, it's not that simple. And value of g is 10, so I'm directly writing here 10 meter per second square. Can we write value of acceleration minus 10? Think about it. Okay. And the distance traveled by the body will be 200 meter. So this description puts lots and lots of question for it, like initial velocity is 0, acceleration is 10, why not minus 10, s is 200, can it be minus 200? So just I'm keeping all those things aside. Here the situation is same, but this time body is thrown with velocity 10 meter per second. Again acceleration is 10 meter per second square and s is 200 meter again. But here situation changes. We have thrown it upward. It will go upward and will come back and then fall on the ground. So clearly, if intuitively we see this, right now I'm not writing the values for this, but intuitively we can see that this will take lesser time, this will take more time, and it will take time in between both of them. Just we can say this thing intuitively. Okay, now uh, if we are going to solve this straightforward, s equal to ut plus half at square, and s is 200 because ultimately it will travel 200 meter. It is a bit messy. 200 is equal to ut is 0, there's half is 10 t square, 5, it will be 40. So t is equal to root 40 second. I am not interested in its decimal value, but it is somewhere between 6 to 7 seconds, maybe 6.4 second. We'll check it out later on. Let's come to this. Here again the same thing, this equation of motion will be applied. So 200 is equal to ut means 10t plus half, and that is 5, and if we divide the equation by 5 it will be 40 equal to 2t plus t square. So t square plus 2t minus 40 equal to 0. And now we will apply that quadratic equation, quadratic formula. So according to quadratic formula, it is let me remind you that quadratic formula. So this t will be equal to minus b plus minus root b square minus 4ac divided by 2a. So here minus b plus minus, I am taking only plus, because if it would be minus then time can not be negative. So b square, that is 2 square, 4 minus minus plus minus 2 plus only plus 164, and 164 can be written as 164 41 multiplied by 4, so we can write it 2 root 41, and finally it will be it will get cancelled, root 41 minus 1. So there was 40 which I told you that it is between 6 and 7. So it is also between 6 and 7 minus 1. So now it is between 5 and 6. And I'm guessing its value as 5.4. As I told you, later on I will find it out, but um, right now I am just interested the way we are solving in it. Now this one, what can be done in this situation when body is thrown upward? So let me tell you uh, one interesting fact. When because this is a uniform accelerated motion, and x direction of acceleration is always downward, so the time it will take to reach this maximum height, it will take the same time to reach the point of projection. So what we can do, we can just find time taken to reach the maximum height, and then we can double it, and then the velocity by which it was thrown, the same velocity will be there by reaching this point, but that is in downward direction. The velocity by which it was thrown upward, the same velocity it will acquire when it reach the same position. And then we can solve it like this. So there will be, we can solve it for upward motion, we can double the time, then we can solve it for downward motion, and we can add them, we will get the answer. But there is another way which can be confusing. As I suggested you, you can solve it by this way which I have already suggested you. but I am using that other way. And see, now you have to think differently. What I am going to do, I could apply here also, but not needed. They're also simple, only one directional motion. We can directly use what we have learned so far. We can directly apply the values in such cases when there is only one directional motion. But here the problem is it is going upward and just not reaching there. It is going then further downward. So in such cases, we use this modified equation of motion. I have given its derivation when I told you, I taught you about derivation by calculus method. So there I introduced this thing. Why we haven't used it here? Because once again I repeat, when we have this straightforward method, why to go for such complication? This is only the case. So here, this S naught, if we are observing the motion with respect to this ground, this is 0 position for us and it is already at some height. So S naught here is this 200 meter. Why have we taken S here as 200 and why is no S not there? We can take, but once again I'm saying, when we have a straightforward method for one directional motion, why to choose such complicated form? This is only the way. Okay, then U is 10 meter per second, and now a special mention, A is minus 10 meter per second. Why is it so? Because some people will say because in upward direction G is negative. No, G is not negative. G is just a number that is 10 meter per second square. Actually 9.81 meter per second square to be very precise. But why negative? It is because we have chosen a convention here which we haven't expressed, that upward direction is positive. U is taken positive, but acceleration due to gravity acts downward. So that should be taken negative. Why haven't we chosen acceleration due to gravity negative here or here? Because it is not needed there. So I will explain it later on. If we apply the same rule here, what changes will be there and how the answer will be the same, and why are we choosing this straightforward method instead of this complicated one. So, and when to choose this complicated method? Only when the motion is in two ways. From the point of projection, it is in two ways. One, it is going up and then passing the point of projection to other direction. Then apply this. Just focus yourself here. Okay, now we can apply that equation of motion. Okay, so S, oh, one more thing, one more mention. S is 0. When it will reach the ground, it will reach our reference level. So S is 0. So minus 200 is equal to ut, means 10t minus half 10t square. And if again we will divide it by 5, this is 5 actually, So this is minus 40 equal to 2t minus 5t. Oh, sorry, this time 5 is deducted, I mean cancelled, t square. So it is t square minus 2t minus 40 equal to 0. Again, apply quadratic formula. So t will be equal to minus minus plus 2, and we will take only positive value. We can take negative sign also, but inside the this discriminant term, that will be a bigger number, so we are avoiding negative sign. B square 4 minus minus plus 160 divided by 2. So this time it is quite easy. It is 162 as we did here. That will be 2 plus 2 root 41 divided by 2. So finally t is 1. It is somewhere between, between, and I suppose it. If we apply the same method, this would be S naught. Then S is 0 minus S naught is 200 is equal to U is 0. UT part is uh, will be removed half, and then acceleration would be negative, so minus half 10 t square, because it is downward. So, and now negative negative will get cancelled, we will again get the same term. So that is why you can follow this standard method, but I suggest you that for one directional motion, if you are going just upward or just downward, or in fact upward and downward at same level, then no problem, just apply uh, that conventional way. But if it is going this way, then apply this standard form. And what are the means is it only limited up to this tower projection? No, there can be an ascending hot air balloon, and if we drop something, see, not throw, just drop something, then the object will acquire the velocity of the ascending balloon, and it will not go downward, but first it will go upward. It will acquire that velocity. So in such type of problem, or during rocket propulsion, it's a detached part. So it, if it is moving with certain velocity, its detached part will also have that velocity, and then it will not directly fall downward, but it will acquire that velocity in upward direction. So all those situations will be dealt by this way. So you can try such problem of your own. And by the way, in all these problems, they can ask for final velocity, so you can follow the same way. Here the conventional v equal to u plus at you can apply here also. And for this, because we have time now, then you can apply that formula, v equal to u plus at here also. Okay, moving ahead. Probably this is the last problem for this video. If v equal to v naught minus kt for a particle which was initially at origin, means initial position is at 0, find the position of particle when its acceleration is 0. So in such type of problems, first understand what is happening in this question when its acceleration is 0. So first differentiate it. Differentiate the velocity, then we will get acceleration. dv by dt. So it is d by dt of v naught minus kt. So that will be, differentiation of this constant term is 0, then minus k will taken outside, dt by dt, which is minus k. So acceleration is constant. Acceleration can never be 0 in this case. A is constant, so it can never be 0. So S cannot be obtained for given situation. See, if not, if it would come with some other uh, equation type of thing, like with some variable t, then first we will put that value equal to 0, then we will find the value of t, and we then integrate this and find the expression for s, apply that t there. So we will see that kind of problem, but that was it is it was given a confused based question. So because here we have no, there is no t here, so because time expression is missing, so and it is constant acceleration, so it can never be 0. So the question ends here itself. So all right, that's all in this video.